Thank you for joining. Yeah, let's just get right into it. I don't know if anybody clicked on that QR code. We'll come back and we'll talk a little bit about that in a minute. Quick introductions. My name is Rick Hogg, and this is my colleague Anil Gersel. We're going to split this session, and I'll do a little bit of talking and kind of give an overview, and we'll kind of navigate around a little bit and talk about who we are. And then Anil will come back with all the fun technical details that perhaps what you came for to learn about PayPal and Reactor and our reactive plans moving forward. So with that, this is how you can get a hold of us. I don't think either one of us are real active on Twitter, but yeah, if you find something interesting here, yeah, do mention us there. Okay, so what do we hope to accomplish today? So first of all, I think it's important to understand, who PayPal is, and we're going to kind of narrow the focus. We'll talk real briefly about PayPal, who we are, what we stand for, and then our role in the organization. We're part of a platform team, but more specifically part of a frameworks team, and that's really where it comes in with Spring and, of course, Reactor. Another thing that's important to take away is kind of the thought process that we go through to implement change. We have a lot of customers building on our frameworks at PayPal, and they have expectations that we have to be considerate of when we introduce new technology. We can't just jump around. It's very important that we're considerate of that change. And yeah, really what we're here to talk about is our JVM frameworks and where we're going to go with that. So we'll jump into that. And then, like I said, Anil will come up and we'll talk about kind of those technical details around that, what challenges we've faced, and how we're contributing back to the community there. So, quick story. A friend of mine who does a lot more public speaking than I did, he coached me one time and he said, Rick, the most important thing in being comfortable and getting the audience's attention is the first 2 or 3 or 4 slides. You've got to have those just nailed down, the talking points, because that's your audience. You've got to get your audience quickly. So along that line, this is my 3rd slide. So you might think, what is the relationship to this conversation right here? A month ago, I was in Colorado, and I made a wrong turn off of a mountain pass, and you can see I ended up going off of a cliff, 70 feet. And when I looked out in this kind of atrium, this lobby area, I was kind of estimating and looking at the ceiling, and I'm like, yeah, that's about how far I fell. So I'm happy to be here talking to you guys about PayPal and being at SpringOne, but I'm actually happy to be alive at this point too. So miraculous story that I was able to kind of climb out of here with only a little teeny scratch. If you saw the QR code and you scanned it, you'll actually see the whole video off my GoPro, which I had just bought. So coincidentally, it was a pretty neat experience. I say it's a neat experience to survive, and I could actually have a session on how to manage a viral video at this point. But how do we tie it to this theme? I thought it might be fun if you guys want to participate. We'll get you guys a PayPal t-shirt if you want to create kind of a funny meme along kind of the theme of this, because I look at this and go, hey, we're talking about reactive programming. Hey, there's failure here. There's resiliency probably. There's streaming, right? So maybe have some fun there if you want to participate and send it on Twitter or email us. But pretty fun story to talk about. But back to topic here. So who are we? Yeah, we're PayPal, right? Hopefully you know PayPal. We're 20 years strong at this point. And what is our mission? Our mission really is that so that everybody can participate in the global economy. It's not just for the affluent. It's for folks that might not even have a bank account. So as leaders in fintech, it's important for us to build and deliver services and tools that are cost-effective, reliable, secure, to enable that mission. What is also very important, and hopefully this resonates with you guys in the room, is customers are at the center of everything we do. And I suspect that applies to most businesses. PayPal really stresses that. And so everything we do, it really is a customer focus, and we come together as one team to make sure that we can deliver on that for our customers. Our values are all about inclusion. We celebrate diversity, respect for each other, and that really builds strong teams. So speaking of strong teams, So Anil and I are here. We're part of the frameworks team, but we have a lot of representation from the PayPal team here. So PayPal guys, hands up. There we go. So there's a lot of us in the room, maybe half of us. So this is repetitive for you guys, but if you have questions about PayPal, what we do, we are here in Austin. That's the neat thing. So our corporate headquarters is in San Jose, but we have a development office here, and our frameworks team is located here. So we're quite proud of not only what PayPal does, but the fact that we're able to live and thrive in Austin, Texas. We do love it, so come talk to us. In general, PayPal is about 20,000 employees. We're in 55 offices around 31 countries. Yeah, performance, right? This is public information I pulled up, but the important thing is the growth here. The numbers are great, but if you look at the growth, our payment transactions at 3 billion transactions, for a volume of 172 billion in the last quarter, and then this growth in the mobile space, that'll come back in a moment when we talk about how our frameworks are servicing these requests. But the trends are good, and what does that mean, right? We need to support our business. Our infrastructure team supports the business, but we can't have this linear infrastructure growth. So how do we develop solutions that are more efficient, that we can do more on less resources, right? And I think you can tell where that's going to go in this conversation. So narrowing the focus a bit more, we've talked about PayPal. What is the team we're in? Well, we are part of a bigger team called Developer Platform and Experiences. We at PayPal, we have our own platform. And so you can imagine that, our goals are sort of like the pivotal platform, right? It's allow teams to focus on their business needs and not all the infrastructure back end required to host their service. So we do have our own platform. And of course, that includes, cloud infrastructure test environments. Where we fit in is this middleware piece. So we're middleware frameworks and messaging infrastructure. Our folks in the room here also are part of these value-added services. So really kind of outside of the framework space, but very supporting technology of remote configuration. What's so important for us at PayPal is to keep our software secure. Hopefully you appreciate that. Security and availability and compliance are really our top priorities. So how do we keep our software secure? Well, you can't have old versions of dependencies out there on our site. So we minimize the friction to upgrade through particular tooling. We also can actively and passively patch software that's in our live environment. And we have a support team. So PayPal has, say, 3,000 engineers. A lot of them, 2,000 of them, are working on the products that are built and supported out of this team. And so to make sure they're successful, we have a dedicated support team and training organizations that build curriculum around making our team successful. So now we're going to narrow. We're going to get a lot closer to maybe what you came to hear about. And let's talk about frameworks at PayPal. So we are a polyglot, and you might know, maybe not, that PayPal, again, 20 years, our business was built on a C++ stack. And that stack was proprietary, tightly controlled. Full stack, that was terrible to work in. Build times, hours, you guys might have been there in your past. But we have a lot of traffic, a meaningful amount of traffic still going through this legacy C++ stack. Developer experience is terrible. So 12 years ago or so, service-oriented architecture comes, other languages come in. We introduced Java both on the front end and in the back, the middleware. And we determined pretty quickly that our Java solution wasn't good for our front-end developers. It was too slow. And so Node.js got introduced, and fast iterations, and it was very quickly adopted. I want to kind of qualify some of these numbers here. Traffic numbers, you might go 2%, that's not a lot of traffic, but 85% of all the web traffic has moved from the C++ stack to the Node stack. And that number at the end, revenue, 50% of our revenue comes through the front door still through our Node stack. So it's a very important stack to us. But with that increase in mobile, we're bypassing that node front end, and a lot of it's coming through most of it's coming through our API router right to our Java stack, our JVM offerings. So you can see a lot of our traffic, 82%. Big numbers here, components, over 1,200 applications are built on this framework here. So, and we'll get into what that framework is. One thing I want to step aside, I really appreciate the Reactor team, the international aspect of this team, and they're coming, they're able to speak so great in their kind of non-native language, I assume. Myself, I might be the hardest one to understand of everybody. My dialect of English, I guess, is from the South. So I would not say reactor, I would probably say reactor. And our product is called Raptor. Well, I'll probably say Raptor. So hopefully you can understand. If something's not clear, raise your hand. I'll do my best. Okay, so JVM, very important at PayPal. Lots of components here. Lots of components that need to be updated and secure. Okay, now we're talking about our framework. It's called Raptor. This is current state. So we're going to talk about current state and where it's going right now. And I say right now because we have already released an alpha version of the next version of Raptor, which integrates a lot tighter with the Spring ecosystem. So you can see the footprint is pretty big, 1,200 applications, 130 billion hits a day on these applications, over 250,000 batch runs a month. So really the sweet spot for this framework is messaging, services, and batches. The front end, again, is done by the node stack. This stack has been around. It's very mature, highly adopted, clearly. But it started years ago when non-blocking asynchronous wasn't a concern of us for many of us. And in fact, it started from our parent company, eBay. PayPal used to be owned by eBay. We had competing JVM offerings then. We adopted Raptor for PayPal. And so that's how it came in. We're at some 30 releases since then. So it is truly our own. And we went to Spring Boot some years ago, which was a big win for us. That second bullet point is going to come into play here with the rest of this conversation. We have a huge investment on the JAX-RS standard. And when I say a big investment, all of those applications, a lot of those are REST services, and we have a governance system around creating and distributing both internal and external services around the JAX-RS standard. Code generation happens, so huge investment. We can't, again, to minimize friction, we can't just abandon that. We have to figure out how that fits into our future plans. 2,000 developers are building on Raptor today, and again, we have dedicated support team, instructor-led courses to make sure they are successful. Okay. We also have another JVM offering, and it's an Akka-based solution. So clearly you saw Raptor is based on Spring. It has been from the very beginning. Scubes. Scubes, again, OpenJDK, Java, and Scala as a language option, but really built around the Akka components. And so originally it was actors. Transition was made to streams several years ago. And really that's found a sweet spot with certain use cases that are high throughput, Kafka, and others, and we've seen really good results, right? It's better resource utilizations. We're able to minimize pool sizes. That's what we want to achieve, right? So why isn't that our answer? So if you look in that top right, we have a very limited number of applications built on this. And because this is reactive, you're all in. That's your option. And we found that certain teams that really wanted to adopt this, they've been very successful with it. But the larger PayPal ecosystem, it's been more of a struggle. It's been more interacting with the team one-on-one, making them successful, but we can't scale to do that. And so we also have multiple teams or folks working across teams, the Raptor stack and the Scube stack, and we weren't going to be able to scale to keep both of these stacks moving forward. So what do we need to do, right? We need to figure out how we pull these things together and have a unified framework that we can support all of PayPal engineers the way we need to. Okay, so now Okay, spoiler, it is building on our Raptor stack. Okay, so how are we going to go do that? So Neil and I are technologists, but sometimes I go a little stupid with PowerPoint, so bear with me here. What I'm trying to show here is what Raptor looks like today. You saw some of these logos a moment ago. Yeah, we're built on OpenJDK. It's 8 right now. The language primarily is Java. There are teams that innovate, and they're playing with Kotlin right now successfully. That's one thing I want to make sure I clarify here. Our principles are to provide for the 80% use case at PayPal. We're not going to be able to satisfy everybody, but we need to be very opinionated, provide solutions that work for most of those use cases at PayPal, and not get in the way of the 20% that want to innovate and get ahead. So, we do support that very well. What I want to call out here is, yes, we're based on Spring. This is boot 1 here, the current release. Yeah, Tomcat, REST Easy is where JAX-RS comes in. Spring Batch, Spring messaging is through Spring integration. But what you see on this right side here is really the mess that happens. Over time, we needed these point solutions. So we have these libraries that have proprietary logic that metrics. Why do we have our own metrics API? Well, we do. We've chosen the Apache HTTP client, but then we needed an async client, right? So we piecemeal threw something in there, and it's serving our customers well. We put in RX Netty, so now the RX Java API, RX Java 1 comes in. Teams start building on that with kind of little direction from us, struggles, how do we do these chain of observables? What does that mean? I've got async servlet and trying to manage that, and now we're not able to give clear patterns for our teams to follow. So we need to change this. And so now it's fall, and we do a 3-year refresh of our stack, and guess what's going to happen? All right, you saw that coming. So Raptor 4, we originally wanted to call this Reactive Raptor, but what we've learned is reactive's not for everybody, and it's not for everybody at PayPal, and it won't be. So to push it in the name actually was concerning folks, right? The awesome thing that the Spring community has done, and we're just following suit with that, is it's about options. And that's really what's going to be the differentiator for PayPal. If you are ready to take on reactive programming, we're going to have the tools built into Raptor 4 for you to do that. But the nice thing is your imperative approach is going to work. We're going to have easy migration from Raptor 3 onto Raptor 4 for that. So how are we doing it? So swap some icons around. The big thing here is we're going to boot 2. So when we start looking at that, and this whole thing really started last year at SpringOne, having conversations with the Reactor team and other folks in Spring to go, there is a platform out there that has a cohesive set of solutions that are tied together with metrics and config that's consistent. Why are we going off and doing these kind of trying to cobble things together and having those huge investments we have to do on these libraries to onboard this technology? So it became more of an exercise of why can't it be? Why can't it be Reactor Netty as our HTTP client? Why can't it be Reactor Netty on the server side as a replacement for Tomcat? Really following suit with what Spring has done. So now JAX-RS is still in here. So this is what Anil's going to come up here in a minute and talk about how we can follow the direction of what the Spring team has done, but make decisions for our PayPal customers based upon how applications are built today. But the key things here, messaging's changed a little bit, but you see Reactor is throughout this. This is what we are promoting. So we want teams to go build efficient applications. We're going to build our curriculum around whether it is your REST service, whether it is your message daemon consuming from Kafka. The HTTP client will be behind JAX-RS, but it will be Reactor Netty, and we will make the transition to move from Tomcat to Netty, similar in fashion to how you can go from Spring MVC to Spring WebFlux. So Anil's going to talk more about that. I did also put on here, we're going to JDK 11. That's in the works right now. Our code base is not there. We are already at alpha release of this. This is real code. This is not something that we're going to be doing. This is something we said we were going to be doing last year. We're doing it now. We already have an alpha release out. This is going to be delivered soon and over the next year, adoption at PayPal. And so hopefully next year we can come back with those lessons learned and talk about those scaling numbers of what we're seeing through this transition. That will be fun. I'm going to close and turn it over to Anil. I kind of grayed out this Kotlin logo because when you look at Scubes and there was a language choice with Scala, we're certainly hearing from our customers that, hey, I want a more concise language option with the Spring and Kotlin relationship that's there and the support. And teams already doing that at PayPal. We're going on a path to support that. What does that mean for us? All of those tooling, the upgrade tooling, the support organization, all of those kind of supporting functions have to be ready for that. So it's not just as easy as, hey, Kotlin works, yeah, it's going to work fine, but we have an investment from our organization to make sure PayPal's successful with that. So with that, it's my time to step aside, and now we get into some of the fun details, and Anil will take us through that.
Thanks, Rick.
Yeah.
When we first started Raptor 4, one of the very first things we needed to do was to pick a non-blocking HTTP client. The microservice communication within PayPal is still heavily, we do a lot of messaging, but still HTTP is heavily used in microservices communication. So in the current stack, we have Apache HTTP client for the blocking solutions, which is fronted by JAX-RS API, which we're quite happy, stable, and allows a lot of customizations for us to instrument or whatever. Quite happy, but it's a blocking one. So as Rick mentioned, for the non-blocking scenarios, we were using Reactor Netty. And as part of this effort, the team is unifying, right? And for that unification, we need to be unifying our HTTP client. We cannot afford to have different solutions for different scenarios. At least reduce as much as possible. And Reactor Netty was end of life, and that's not an option, so we need to pick something else. And since we decided on Reactor Netty comes out as a natural choice, of course, because Netty is already proven, and Reactor Netty provides a really nice API around that on top of all the goodies that it provides, like back pressure, metrics, etc. But we did a quick check, comparison, with some other HTTP clients, like Async Apache HTTP client, JDK's and Async HTTP client. Overall, Reactor Netty was on par or better. I'm not just talking about performance, but features and support and other concerns as well. So once we decided on that, the very first thing we did is to integrate it with our JAX-RS implementations, which is REST Easy. And so we made a contribution to REST Easy team, and they were very welcoming on that, a Reactor Netty based client integration. So and they provide a lot of feedback as well, and it's there right now. So once we worked on the HTTP client and got a little bit more confidence, we decided that, all right, from now on, we will try to get all our I/O needs via Reactor Netty. We have our own metric collection mechanism that needs to do some I/O. We have our own logging infrastructure, which all applications talk to a local daemon. That we did a POC around using Reactor Netty for that as well. For some for some data access use cases, we are exploring this as well. The goal basically is, yes, on one side we would like to reduce the resource, basically share the resources as much as possible. We don't want to keep creating threads for different use cases. But the other thing is standardization, whether it's metrics, connection management, or logging. We would like to be able to standardize for all I/O operations. So that's the plan going forward. So again, PayPal has been for many years have been using JAX-RS heavily. So and JAX-RS 2.1 provided significant improvements on async use cases. And I'm going to be in the next slides. We'll be talking about what we did, how we use it, and what we did, how we integrated with Reactor, with JAX-RS, and things around that. So first, let's start with the HTTP client. So here's a sample HTTP call with JAX-RS, blocking one, right? So you do from a client object, you create a web target on which you can do customizations like path, query, param, etc., whatever. But then you do .request and .get or .post, .delete, whatever it is, and get the response. So JAX-RS 2.0 had an API called, after the .request, you could do .async, and it would return you a feature. But that was a Java util concurrent feature, which is not composable, and you can't do callback. Pretty much like not very useful, right? JAX-RS had an invocation, like another API, which allows you to register an invocation callback, but that had its limitations as well. So in 2.1, there's a new API called .rx. So the name of the API may not be the best choice, probably, because it's probably infers some specific technology for a specification. But it does the job. So basically, when you do .rx, now it returns you a completion stage. So it's in the specification and requires all the implementations to support this. And the specification also allows, JAX-RS specification also allows returning different reactive types. For instance, you can do like this. So you can do .rx, return me a mono, and from your HTTP client, you'll get a mono. This was a contribution to REST Easy by our team as well. But there's always a but, right? There's a problem, and this very thing that was supposed to be there for non-blocking was actually blocking. I mean, it wasn't blocking the thread that you make that API call. For instance, if you make that API call in a Tomcat thread, it wasn't blocking that one, but it was moving to a different thread pool and blocking a thread over there. You basically move the problem from here to here, maybe even making it worse, because now you have two thread pools to configure, and maybe it's getting even worse, right? And we checked other JAX-RS implementations at the time, like Jersey and CXF as well, and surprisingly, they were blocking as well. And we thought, like, is this a problem with the specification? And we started looking into the issues of the specification, and there was a discussion about this, actually, surprisingly. But the spec authors made it clear that, hey, specification just talks about the API, doesn't really gets into the details. However you implement it is up to you. I mean, I have to say there are some improvements, possible improvements in the specification. In some async scenarios, there are still some synchronous APIs being passed around. But anyway, so we digged into REST Easy code. We were able to do a lot of refactoring around invocation logic, and we were able to make it the first truly non-blocking JAX-RS implementation with the contribution. So we were able to like basically pass around that. The next problem we had was around performance. So when we compared after the integration, the Reactor Netty integration, when we did the LMP performance comparison with the previous version, we saw significant degradation. Like the throughput was low, but especially the 99th percentile latency was going off the roof. Like it suggests GC usually, right? And we were kind of like, since we already had some Reactor Netty related performance verification, we were kind of like surprised seeing that, and we thought maybe it's about our integration. The way we integrated is probably the problem. But anyway, looking into details to JFRs, the Java Flight Recorder analysis, and it turned out that REST Easy is actually producing a lot of garbage. And during this process, like when we did the integration, started the new project, we also upgraded the REST Easy version. Apparently, like we moved to REST Easy 4, looks like around 3.6, they introduced a new change, and that apparently caused this. And the reason they did that was to apparently there was a gap in one of the spec requirements, and they wanted to make sure. And the spec, here is what the spec says. So the web target object is kind of immutable. It's not immutable, but kind of immutable. Like when you do .path, when you add a new path parameter, like it returns a new web target object. When you do .query param, it creates another web target object. But when you would like to do a configuration change, it keeps the same object. What do I mean by configuration? For instance, you want to have a request response filter, or you want to have a message body reader writer, like for serialization, deserialization, or interceptors. When you register those to the web target object, it's not modified. It makes the change on that specific object. And the specification requires that when you create a new web target, for instance, with .path over there, those two web target objects should be detached in terms of configuration. If you make any modification on one of them, it shouldn't be impacting the other one. And REST Easy kind of like support that was with every web target creation, it was making a copy of that configuration. And it was getting quite expensive. And that was where the problem. And at least for our scenarios, and I assume in most scenarios, this configuration changes usually happen during startup time. During runtime, you don't do too much, but you keep paying that cost every single, and even in just this simple example, you create 3 web target objects and you end up copying it 3 times, and if you have multiple calls within a single scenario, then it kind of like exponentially goes. Anyway, so we made a few contributions to REST Easy project to basically refactor those data structures to be copy on write. So with copy on write data structures, we basically eliminated that copies and it brought our performance problems, eliminated our performance problems. So I'm now going to be talking about the server side. So here is a sample JAX-RS endpoint. I assume like it's pretty similar to Spring MVC with some annotations like .get, .post, etc. In this specific use case, it's going to be returning the hello world string for a GET request to sample/hello. So JAX-RS 2.0 had support for asynchronous endpoints, but it was requiring like the method would be having a parameter like async response parameter, and then if you would like to resume on that in the method body, you would be returning a async response.resume. I mean, it was doing the job, but it wasn't as slick. So in 2.1, they allow returning a completion stage, which made it a lot cleaner, a lot easier to read, and it helped a lot. It also like helps us in different areas. For instance, makes it easier when we have some tools to generate like these interfaces from API definitions. So those two, I mean, we haven't implemented those yet, but it helps a lot with those scenarios. We also use REST Easy's capabilities around proxy client injection. Like some teams prefer to use like more RPC style calls. So they can, like with Spring Magic, we can basically allow them to inject a specific type, which underneath makes an HTTP call. So in such scenarios as well, it gets kind of like better with the REST Easy integration. But if you look at the message body, it's like monos and like maybe fluxes, whatever. So because that's what we said, like we will be moving more towards Reactor, and that's. So what happens is at the end you need to do a 2-feature. Basically, there's a boilerplate. So if I'm dealing with monos or fluxes, why do I need to convert to completion stage? So it turns out REST Easy also allows us to return, like to register and to return the mono. So we're getting closer to WebFlux. So this was a contribution to REST Easy by our team as well. So with this, the teams will be getting closer to WebFlux, and we actually would like to move to WebFlux ultimately. And that's in the plans. So one of the nice things about WebFlux is so we have Tomcat currently, the servlet container underneath, and it can work side by side with the JAX-RS endpoint. So there may be some trickiness in servlet mapping areas, but still they can. I mean, at the end, those are like registering as servlets underneath. So it can work side by side with JAX-RS endpoints, and teams can slowly migrate to WebFlux, like the Spring annotations slowly. And when they move all of the endpoints to this new style, then with just dependency update, they can change from Tomcat to Netty, basically. So that's pretty nice migration path. But I mean, as Rick mentioned earlier, there are like 1,200 applications, and maybe not all of them needs to migrate, right? Maybe but at least a few hundred of them. Still many applications. So there's going to be some adoption friction. So we have a tool called Butterfly, which is an open source tool as well, one of our team members. But I mean, it won't be able to. I mean, the annotations are easy to change, but it won't be able to update the code 100%. There's going to be some friction. But I mean, we're closely looking into that, how to make this migration as painless as possible. And if we do a migration on the server side, we'll definitely do it on the client side as well to make sure it's consistent across. So in the meantime, we are exploring also to use Netty underneath JAX-RS. So one good thing about JAX-RS specification is it doesn't require servlets. So by default, it works with servlets, but it also says you don't have to and the API doesn't have anything about servlets. So, and actually REST Easy has already integrations with different servers. Like it already has an adapter for Undertow, like a service plugin for Undertow and Netty. And we did a POC about this, and we were able to use Netty on the server side and Reactor Netty on the client side, share the resources with just only a few threads, like the number equal to number of cores. We were able to run a Raptor application. Of course, this would require us to do some cleanup, which same thing we need to do for WebFlux migration as well. Since servlets has been there for a while, it was assumed it is there. So we have some servlet filters for different scenarios. Those needs to be migrated to either WebFlux filters or JAX-RS filters. Context initialization hooks of the serverless needs to be migrated. And the other thing is the Spring request scope beans rely on this. So we need to find some ways around that, or maybe eliminate some of them. So the next step will be doing a detailed LNP around this and see if we see promising results. This might be an in-between state for us to get the applications to Netty. And this will be if we decide to invest on it further, and if the results of LNP comes up good, and if we decide to invest, this will be a contribution to REST Easy as well. The current Netty integration of REST Easy, that would probably require some modifications to make it more customizable for us, but we actually would like to get Reactor Netty over there. Again, the same story for all I/O. We want to use the same library, and also if you check 0.9, there are a lot of metrics that are provided by Reactor Netty. So anyway, so if we decide to do this, this will be a contribution to REST Easy as well. So a few helpful features that do throughout this work, like some features that helped us a lot, is I would like to talk about some of them. So the first one is a timeout operator. The request timeout is critical at PayPal. Like all the applications rely on that. And so far in the existing stack, we were using Hystrix and relying on the timeout capabilities of the Hystrix. In the new version, in the next version, we're not carrying forward with Hystrix. The main reason is Netflix is put it into maintenance mode. And the other thing is Hystrix was actually hard to configure. The configuration was quite complicated, and it was heavy. Like you had to have a different thread pool. It was allowing to use a semaphore as well, but again, it wasn't as easy. So we're moving to Resilience4j for the next release. We already integrated with Resilience4j. But I mean, technically, what we would like to get to is, and we try to do is, like any capability we have in the framework, it should be configurable. Basically, it could be it should have a toggle and it should be disabled. And if some teams, for whatever reason, may not want to have a circuit breaker, but they should still have a timeout feature, right? So Reactor Netty doesn't have a timeout feature by itself, but Reactor itself has a timeout operator. So if there's a mono doesn't pass an element within the given duration, it'll just throw an exception and kill the stream. And we basically updated our REST easy integration with Reactor to include this. I want to mention one thing. The Reactor team was very helpful throughout this journey. Like on Gitter, they are always very responsive, and they helped us in many of our conversations. And even just yesterday, I was talking to Violetta. She kind of like helped identify a problem with the timeout as well. So thank you for that. So the other one is the bounded elastic scheduler. It was released a few weeks ago, and one of our team members were also like asking questions about this like a few months ago on Stack Overflow. I think Reactor team already had plans about it, but they were responsive and kind of worked on that. So what does it help with? So even if, and we want everything to be non-blocking, but the reality is there is some blocking code. Some applications, especially JDBC scenarios. And Oracle canceled the ADBA project, but there are some good news about fibers, and JDBC apparently will be using fibers, but we don't know when it'll be available yet. It's a few years ahead, I guess. But I mean, even outside of that, there are some blocking use cases that we have to deal with within this application. An important thing in an async application, the important thing is if you have blocking logic, you have to isolate it to a separate thread pool. Otherwise, you will have to deal with all sorts of weird issues, and you won't be able to use your resources in the best way, and also you will have to deal with a lot of interesting bugs. So far in RxJava and also in Reactor, the practice was to use Elastic Scheduler for any blocking needs. And the problem with Elastic is it's unbounded. Let's assume your database call is slowing down and keeping the threads busier so that those threads are not going back to the pool as fast, but your incoming requests keep coming. Whenever you ask, it'll keep creating new threads. And ultimately, there's a possibility that you may get into a state that you have so many threads that your application is not moving at all and consuming too much memory. And you don't want that. So at some point, it's better to fail faster rather than getting your app to a state that it's not functional at all. So bounded Elastic is, I believe it's going to ultimately replace Elastic. Maybe there are plans around that, but it's going to be pretty useful for us. The other feature around Reactor that we utilize quite a bit is the hooks for asynchronous boundary crossing. So we have the logging library, like our proprietary logging and tracing together library and infrastructure. We do tracing across the applications, but we also, like within an application, when a request comes in, when it goes through different threads, we would like to trace all the logs and correlate all the logs within an application as well. And Reactor has this nice hook points where we can migrate all the logging context from one thread to another. We looked into Salute projects quite a bit to understand what they do and try to do similar stuff around that. I think there's a significant improvement area over here still in the Reactor land, but it's so far we are able to, for the most part, able to address at least our HTTP scenarios. But there's always a corner case where it's dropped, etc. So as we identify, we try to address those. But it's a tricky area to deal with. But it'll be good to have per element context object being traveling through the stream. That would like the Akka stream ones, like Flow with Con. That would be really helpful, I guess, in Reactor. But this is so far addressing most of the scenarios, at least until we find the next problem. The next important item from Reactor is the micrometer integration. So 0.9 has all sorts of like metrics around DNS times, the resolution times, connection metrics, and HTTP request response times. Before, we were doing these ourselves. We had to, in Apache or whatever, and even for Reactor, we attempted doing some of them ourselves. Now, all we need to do is like just do a micrometer registry for our own or our own metric implementation and just like use micrometer and get all that data. So that's really useful. And Resiliency 4J also seems to be using micrometer, and yeah, it helps a lot. So far we all talked about HTTP, but PayPal heavily uses Kafka. One of the largest Kafka uses like 500 billion Kafka messages a day processed. There's like 40 clusters. The use cases differ, like there's quite a variety of use cases. Analytics, risk fraud detection, data center replication, data pipelines, machine learning scenarios, like there are a lot of variety of use cases. And we are looking, the messaging team, which is our sibling team, are providing a Reactor Kafka-based solution for Raptor 4. Again, it's not going to be a requirement. It's not going to be you have to use Reactor Kafka. It'll be offered with Spring messaging. So you will have a choice, basically. Whenever you feel comfortable, you can move to Reactor Kafka. So just to summarize, our team provides tools and libraries to migrate, to build new or migrate existing applications to reactive solutions. So currently we are opinionated around Reactor, and we will be building educational resources to educate like the rest of the engineers in the rest of the engineers in the company towards reactive programming, and probably later on we'll share some learnings about that as well. But the important thing is the teams will be adopting these at their pace. So we're not pushing them. So it'll be at this point based on their needs. They'll be adopting the reactive patterns, and Spring team and Spring solutions help us to have a cohesive solution around that for both imperative and reactive needs. So thanks so much for joining, and if you have any questions, we'll be happy to answer.
Thank you. No questions. All right, well, oh yeah.
Yeah, so I know that this is a journey and it's still in development, but is there like an ETA or like known date when like your first production Raptor 4 app is going live?
That's a good question, and that's where we're at right now. In fact, there is one of our colleagues on the second row there. Mike and his team, he's the architect of an analytics platform that's built heavily on this Cubes framework we talked about. Been very successful for them. So we're partnering with them to get one of these use cases brought over to Raptor 4 on our alpha or beta release as soon as possible. We're starting that to start getting that data. We'll be GA soon, and then it'll just be a matter of kind of adoption. The nice thing at PayPal, I say nice thing, from a frameworks perspective, we've always kind of struggled of getting teams to do the work to upgrade. Well, our security posture over the last couple of years, addressing security vulnerabilities has really helped us there because it's on the teams. They have to upgrade. So that really gives us a course to kind of put Raptor 3 in maintenance mode, sunset that at the end of 2020. So we'll have to get adoption over the next year. So soon, I don't have a real good answer, but we're working with Mike and his teams to really get their use cases over. Thanks for the question.
So how do you select what sort of workload would be good for not blocking anything like that?
Yeah, I'll let Anil probably take us through that.
I mean, in general, of course, like you would prefer a non-blocking scenario pretty much for every use case, I would say, if you don't want to waste money, right? But I mean, sometimes developing or migration is also a cost to the company, right? You can't put like 10 people working on it if you're just not gonna be getting any benefit out of it. So I can't give you any number like if you're taking more than this many requests, you should be doing it or not. I don't have any number. I don't know if Reactor team has any number on that as well neither. But in general, I think for new applications at least, they should try to adopt it.
And
not necessarily maybe Reactor, but something non-blocking, like not to waste resources, basically.
Right. Yeah, it's going to be a learning process for us this year, and it's asking the questions. Sergey had a great session yesterday about do's and don'ts of reactive programming. The takeaway there for us is to go back and use that when we talk to our developers. It should be a pretty easy story to sell. We have huge application pools, right? If we're doing 130 billion hits a day, right? We've got huge application pools and infrastructure costs there. So if you can go to a team and say, hey, we have a path and a new model you can build your application in. If you'll adopt that, we feel like your pool size will reduce significantly. And at the end of the day, we all work for PayPal and we want to do that with less. It's just how do we formalize that message? We need to learn that ourselves. So. You have any advice there?
You saying that React AHS would be solving for them unless you are rewriting that to make it so easy. Right? That's what you're saying.
That's what we believe. We need to get to non-blocking. Clearly, we know that. We can't be blocking, that's wasteful. How you do that? I mean, at PayPal, we've had very different solutions for that. They weren't necessarily non-blocking. We talked about Reactor Netty, but we have these libraries for just doing parallel workloads. We know we need to be opinionated around here is the path that we think is the right choice for PayPal to build asynchronous, non-blocking applications that have back pressure, right? And that's where we've come in, and we will promote Reactor for that. Next year, we'd like to share how successful we've been with adoption and what we see of those 1,200 apps. How many of them have adopted the reactive approach, and what has been the financial gain for us will be a good story, hopefully.
Do you have any idea on what the performance savings is going to potentially be going from Raptor 3 to Raptor 4?
Not at this point. I think it's going to be more stability, tighter SLAs, lower CPU. And any examples, until we get a real PayPal use case. These contrived examples, of course, we can build something and look, this has a good profile, but real business use cases is where we're going to get that data, and that's where partnering with Mike and his teams, rolling out. So the plan is we have a pool that has the Scubes version of their app. We're going to port that to Raptor, and we're going to put the Raptor instance in the same pool. And we'll be able to watch the traffic patterns and evaluate Raptor 4 and improve on that where we need to meet, ideally meet or exceed where we are with the Scubes framework. That's what we need to do.
So the reality, though, is like that number will change from application to application, though, right? So there can't be just one number for the entire thing. And especially for the database-heavy applications, the number will be pretty low, I guess. So it won't be too much benefit. It will be a little bit, but at least it will prepare us for whenever there is an available non-blocking or whatever blocking fiberized JDBC client, it will be prepare us for that. But again, it will be based on the application use case. The numbers will change. Yeah.
Will there be any R sockets?
So we don't have immediate needs for that. Certainly we're interested in this, and as I'm learning this and we can understand back pressure within the context of a process, When our sockets can deliver that back pressure across sockets or processes, and we have a reactive system, that's very promising. We'll be a wait and see on that. I mean, PayPal with so many interconnected services with different stacks there, rolling that out will be a challenge. So we'll pay attention, but no plans right now. Certainly interested though.
I'm just interested in finding out like what is the team size that is working on this effort actually.
So this specific effort, we are 5 people team. But these 5 people are doing some other stuff as well.
And no, why I'm asking is like this is I cannot resonate more to this session than what I'm doing on a day-to-day job actually, and the kind of issues and we are on exactly on the same journey at Adobe, so same team and everything. So I just wanted to figure out. And how much time have you spent on this effort?
We've been working on this since May or April, around that time.
Well, it started a year ago. So we went to SpringOne in DC area, and we knew we needed a unified framework. We've had these frameworks for years, and we can't make either one of them the best that they can be because we're kind of focusing on both. So we knew we needed to unify this. And when we went to SpringOne last year and having conversations with the team, we really got the confidence that we have this big footprint on Spring. Spring is evolving this. They've got a cohesive solution. Reactor's there. We had already played with Reactor years ago. We liked what we were seeing. The fact that it's interoperable, right? We knew we're on RX1. We knew we were going to have to go to RX2 and Reactor interoperable, Akka Streams, right? So the reactive stream specification helped give us confidence that, hey, if we're still, like our caching solution, still returning observables, well, we can plug that in. And so it's been a year journey where we, had some...
The discussion started then, but the actual kind of like getting into the code, dealing these were like, we started a little bit.
Yeah, and the team... we have a big presence here. Some of those other supporting teams, like the tooling for upgrading and patching, that's this team as well. But yeah, the core team is relatively small. That's actually doing the execution of what we've talked about here today.
One final question I have. Like you shared that you did some benchmarking with the different HTTP clients. I think most of the things we are following the same principle apart from the HTTP client actually. So we went with the JDK's HTTP client, but one of the interesting things that I think I found in your slide was like the contribution you did to the STZ in terms of like returning back monos. So the way we kind of did layer on top of the JDK client is returning the publishers basically, and or maybe we can also. So that was one of the things that maybe I'll talk offline with you. But if you can share those numbers, that will be very interesting.
There's a link over there that you can...
I have no way to figure out that link.
Yep. We'll talk.
We'll talk,
yeah,
yeah.
it's open source, and it shows
So
kind of how we did the evaluation.
Yeah, actually, JDK HTTP client has a good option as well. We considered that as well because it's there already. But it would only be working in you won't be able to get it in Java 8, first of all. So that's one model. And the other thing is it doesn't provide a lot of hooks and customizations around. And when you deal with a reactive stream, we can rely on a lot of hooks, like do it on discard, etc. Like those are.
So yeah, that was one of the things that I have open questions for the team as well. Actually, I was hoping to sync up with them. So that is one of the things I'm still not very sure about how we did that. Like the monos and the flux has like back pressure discard or on back pressure do this and all that. I think so. Again, like maybe it's an open discussion now. So so what if we basically the completable features that basically JDK client returns, and if we wrap them onto a mono, will we be able to get those features around like the back pressure thing? If I say like the future dot or like mono dot from future and whatever the completable feature I'm getting from my JDK client, now I have a mono. Can I do on back pressure on those?
So I will let you guys talk first. Then.
Perhaps I can start answering. We already had a conversation yesterday.
Yeah.
So back pressure theme makes a lot of sense when it comes to streaming of multiple elements as long as your action is asynchronous, you can use it as part of your back pressure aware pipeline. But completable future or mono, you can actually think of mono as completable future of steroids.
Correct.
Because it gives you some
Exactly.
operators better cancellation support, because completable future, for instance, does not support cancellation, only ignorance of the result.
Right.
Completion stage does support cancel, so we can implement it, but completable future does not. And the thing is, yes, it is back pressure friendly because it's asynchronous, but back pressure happens in your pipeline and not in this completable future.
And those extra stuff, the steroids, gets really important some, especially for cancellation scenarios, like where you need to do some releasing, cleaning up, etc. Your byte buffers, etc. It gets pretty important. And as far as I remember from reading, JDK HTTP client actually supports back pressure at the payload level. You can do, and it returns a publisher. And if you create a mono from that publisher or whatever Flux, you should be able to get it. But one thing I would like to comment, it was a discussion within our team as well, whether we should expose publisher or mono, etc. One thing about that publisher is, I mean, the reactive streams is an SPI, is not an API, and then publisher is, you can easily screw things up. And for that reason, like relying on mono is, we decided to go mono or Flux in the APIs instead of doing a publisher.
Maybe a big difference between completion stage and mono is that mono is lazy by definition of record streams and cold. So that if you want to retry, for instance, on error, you can just do retry. With completion stage, if you just reuse the same instance of completion stage, you cannot retry because you cannot re-instantiate code. So you have to wrap it with some deferred execution, and then when you retry, you have to relaunch everything from the beginning.
I see. I think that's it. Because retries and resiliency is the notion that we still have to implement in our client actually. So why we decided with this approach was like there are some teams in our organization that doesn't want like kind of a high level constructs on their things like mono or anything to do with Spring. They will not adopt that. So we wanted to keep it as generic as possible, and then maybe provide some higher level constructs on a different basically approach wherein these configurable features can be wrapped. And
Oh, you're going, oh, you
It's
need.
showing that URL. It's kind of hard to see, huh?
My question was primarily around if we return configurable features, can we do this?
Yeah.
I think we can continue offline.
Yeah.
Sure, yeah, absolutely.
Yeah.
I'm still wondering the use case for a reactive framework. Let's say I have a web application with a lot of database operations. So we use JVC and access the database. As you mentioned, it's a block. So in that case, does it even make sense to use mono or WebFlux? Because application is really just access database, and there is no reactive JVC driver available yet.
I don't think you will get immediate benefit. I mean, you may get some benefits here and there, but it won't be a significant benefit. But in my opinion, what would be a good thing is if you're building the application from scratch, I mean, migration may not be the best choice maybe at this point, but if you're creating a new application, in my opinion, it still makes sense. The reason is you're at least designing your application that way. And once you have JDBC driver, which is non-blocking, then when you change that, then you will have the benefits. You don't have to go redesign your app again if you're building from scratch.
Just for the future, right?
Yeah.
There's also another case where it could be useful is if your application also makes requests to other HTTP endpoints or HTTP services on top
You
of the
make a
database.
remote call to
Yeah,
another
remote
service?
calls.
So you can use a web client?
Exactly. Yeah.
Okay.
Using the web client way to composability benefits and performance benefits, kind of absorb all of this latency of the
try, you have to build some nasty code blocks, and with pipeline, just build your pipeline. We did use Spark, for instance, but now we don't need Spark consistent with use case, for instance.
Okay.
Right.
Thank you so much for joining. Hope you
Thank you.
enjoy the rest of your conference.